Hello everyone. I am back. I'm sorry I'm a little late because my cook didn't arrive today. So I need to cook my own food. So because of that I'm a little late. But I am here. Uh, okay. So today is a great day. Saturday weekend. Everyone's most of you are guys are must be sleeping right now. I was also sleeping half 1.5 hour before. But okay. Now I'm here. Let's deep dive into coding again. So today, I'm thinking of, I'm trying. I will be trying to like solve a hard level of questions on lead code. So basically, maybe I was thinking of going with the contest hard level problems. Okay, I am lucky that I got. Let's see. I haven't solved the hard level questions. I don't know, did I solve this minimum array sum? Yes, I did solve it. Ah, yeah, I do remember this. Okay, so I guess the fourth question, which I didn't solve. Okay, and also I haven't completed my breakfast yet, so I'll be like completing my breakfast um, during this time. So please bear with me a little. Okay. Let's see. Let's try to build our intuition on how um, to solve this question, and if we'll be able to build the intuition, we'll be able to solve it. So let's see, and if we are not, then there must be something mm, good inside this question, and that we will be learning today. So let's give it a shot and see what the question is asking. Okay, so the question is, there exists an undirected tree with n nodes numbered from 0 to n minus 1. You are given a 2D integer array edges of length n minus 1, where edges of I is equals to ui, vi, wi indicate that there is a edge between ui and vi with the weight wi in the tree. Okay, your task is to remove 0 or more edges such that each node has an edge with at most k other nodes where k is given. The sum of the weight of the remaining edges is maximized. Return the maximum possible sum of weight of for the remaining edges after making the necessary removals. Okay. So first thing, it is an undirected tree, so there will be, it's not a binary tree. So multiple edges can happen. My task is to remove 0 or more edges such that each node has an edge with at most k other nodes where k is given. Okay. So each edge can have at most k other edge with k other nodes. Means maximum 2 edge they can have. Minimum 0 edge, 1 edge, 2 edge, and not more than that. If there is more than that, I'll have to remove that edge. I need to like the sum of weight of the remaining edges is maximized. Okay. So I have k as 2. So values, okay, this can be like a positive value only, a valid tree and a positive value. So 0 to 1 there is an edge with 4 cost. 0 to 2 there is an edge with 2 cost. 2 to 3 there is an edge with 12 cost. 2 to 4 there is an edge with 6 cost. So I can at most I can remove 2 edges, and if I do not remove any of the edges, each node has an edge with at most k other nodes. Okay, this 2 has an edge with these two, like, okay, we are like considering the hierarchy also, not the immediate child, or all the child from their position. Mm. Okay. Right. Okay. Okay. Is that like mm, I'm thinking of like okay, this 3 when I'm falling back. Okay. Let me change the stroke to a smaller one. So when we are recursing back, we will be like checking uh, whether we are able to like see this or not. Okay, just a second, just give me a second. Okay. Right. So what I was saying is like when we are returning back, we'll check whether how many nodes we have from the bottom. We may keep a kind of a priority queue or something like that, which will give me the maximum total highest cost till now. If the nodes are like smaller, means every position I'll get a list of node, right? K top. um, do we have a better example, kind of, just to have more clarity on this? Two. Okay, there is one more edge from 0 to 6, which is of 10. Okay. So my answer is for this is 65. Since no node has edge connecting to it more than k is equals to 3 nodes, we don't remove any edges. Hey. Okay, so what I was thinking is wrong. Since no node has edge connecting to it more than k is equal to 3 nodes. So like 0 has 3 nodes connecting to it. Okay. So like this is also fine. Why we removed this 2? Node 2 has edges with 3 other nodes. Oh, node 2 has an edge with 3 other nodes. You see here. That's why we removed the lowest one. We had to remove. No edge. Okay, last byte. Now okay, there is something that I need to understand. What if this 6 would have been there and this 2 would have been here? So I know when I fall back to this position, I know I have two nodes in total of, and their values are 12 and 6, right? We have two nodes and their values are 12 and 6. Now when we fall back, I'm saying that we have three nodes, their values are 12, 6 and 2. Sorry, 12 and 2. Now 12, 6 and 2. Now this became let's make it more simpler. Let's try to make it more simpler. What I'm saying, when I'm at this position, how many nodes I can like go to? There is one node that I there is one path from which I came, and rest of the path where I can go will be like one more node connecting to it. And after falling back, I'll say that we have 2 plus 1, that is 3 total nodes. Two nodes which are coming from these positions, and their values are 12 and supposed to. So these are the two values that we are getting. Okay, now when we fall back, we like total we will be having like 3 nodes and 6 value. Okay, so these are the 3 values. Now we have 3 nodes, but the maximum that we can go is only 2 nodes. So what we have to do is like this is 2, this is suppose 6. So I need to remove this edge, and I'll fall back to this position. Now this will not return me something as sum. Now which edge I removed. That too also is one of the thing. I used this edge, and if this was like 2 and 6, the actual one, I removed this edge. So for 0, this edge is disconnected, right? I don't want, so this is a separate, this will be a separate thing, and this rest of the things will be a separate thing, right? So which edge I removed will matter, like if it is a parent edge or the child edge, like that is like affecting, is it affecting even? That is one question. Like if I remove this edge, or if I do not remove this edge, there will be an edge to the parent, right? We'll be returning 1 uh, from there. And if the parent edge is only removed, then we will be returning 0, like there is no edge. So I need to like and what if there are like multiple same values? So in that case, do I need to remove the parent, or it's always better to remove something else for the same values? If I have to uh, should I go for always better to remove the parent edge? What I think, so, because it will like uh, so if there are like multiple, and if parent is there, it's always better to remove the parent edge. See, DFS like we can go with the DFS flow, uh, but logically what should happen? Where, what is the thing that I am missing over here? A proper flow. For each edge, find two sums, one including the edge and one excluding it. What does this mean? Hmm. I'm including this edge, I'm excluding this edge. Okay. So he's saying he must be talking about the parent. if we if we are going from here to here, if I include this edge, what's the sum that we will get? If I exclude this edge, what's the sum that we will get? If I'm including this edge, okay. Mm, it's like taking and not taking. If I'm taking it, how many edges I have already taken? I will not take that edge for like every node. How many edges can we maximum take? Okay, there is something. The input is generated such that the edges form a valid tree. N is equal to 2 into 10 to the power 5. Edges of I dot length is equal to 3. Okay, uh, let's try this approach. I'm starting from like any of the edge, like zero edge, zero. What if I include this edge? My sum will be like 4 here. And what if I do not include this? It's like if I do not include this edge, I will return a 0 from here. If I'm not including, like, it's 0, I'm not even calling that edge. But I will call that edge. For this edge, I might have further nodes, right? So that I need to check whether I should include this edge or I should not include this edge, and that will return, like, after not including this edge, whatever sum we are getting. So including can be maximum, including maximum can be of k. K is the maximum that I can include in total from a current node. Like this node, maximum that I can include is k. It's like from this node I'm selecting 2. So if I'm including this for the next node, already one node will be included. I'm saying this is like, I am including this, so this will be included, right? And if I am not including it, I will pass 0 to the next node that the previous node was not included. So for you to take, you can take like most uh, of the nodes, but if I'm including this edge, uh, I can call this edge. I can call this edge. We will like uh, hmm. It's like for this node, if I have included the previous node, I can include like one more node. Or if I haven't included previous node, I can include two more nodes. So which two node should I include, and which node should I not, because every node will be called with inclusion and non-inclusion. And which one should I include? uh, that I need to like check everyone. It's not always greedily to pick the value, the larger value. That will like create a problem. So I do not have to go for greedy approach. Greedily cannot be done. It's a kind of a dynamic programming DP. It's just I need to understand one thing. I am picking this. Then I can again call the same node. I will not change that. I have picked this node. Now for this rest of the nodes, I can pick, right? And one will be, I picked this node and I called this node, and I pick this node. I do not call this node. I'll pick another node, and if I pick this node and I am calling another node, I'll give k as 1. And if I'm calling the same node, I'll like increase the counter, and then I'll jump to the like I will not use this node. I will like use the uh, other nodes. Right. Okay, this is going to be a confusing code, but I'll try. Like return max sum tree. So we have edges, right? I need to create the graph for this. Vector and okay, should I like go for let's not do this. Let's create unordered map maybe of edges and unordered map of like uv and value. This will be like adjacency list, my adjacency list. This is my u, this is my v, this is my cost. I iterate over edges. I will do like adjacency list on this. Okay, maybe I'll do for each loop better. Auto edge of edges, edge of like u. edge of 0 dot not pushback. Insert uh, edge of 1. No, sorry. Edge of 0, edge of 1 is equals to edge of 2. And also there is like no path to it, so it'll be an opposite side also, that I need to like make sure that I do not. So, I need to like it will be a tree, right? The input is form a valid tree. Like there will be no disconnected component. If I start from any one of the node, uh, I'll be able to reach. So probably I'll start with the edge with only one. I'll try to start with an edge which has only one edge, like that is the root node. No, maybe I'll start with like one, from 1 to 0, and 0 to 2, 2 to 3, 4, and something like that. Or even like I can start from 3, I can start from 4, even I can start from 2. Like, is it like good choice for me to start from 2? I don't think it's a good choice for me to start from 2. Because if I can call 0, I can call 3, I can call 4. How many nodes do we have? 10 to the power 5. And I'm like always getting stuck with one position where I am at 2. There are like multiple edges. Suppose now from here, if I'm choosing any of the edge, then what should happen? Like this picture is not very much clear to me in my mind. If like I'm at here at this position, if I'm calling if I'm selecting this node, should I add it directly over here? And if I'm not selecting, I should remove it. If I'm selecting this node, call again this node with some as that. If I do not select this node, I could I can select other node. It's always pick and not pick. This is like it's a DFS DP. I knew that. DFS will return v1 and v2. v1 is the weight sum of node. v1 is the weight sum of node I with at most k minus 1 children. v2 is the weight of the sum of node I with at most k children. Why is 2 is the weight of the weight sum of node I with at most k minus 1 children. Weight sum of node I with at most k children. For each node I, we recursively call DFS on its children. Compare the diff of v1 plus w and v2 for each child and pick k minus 1 and k biggest improvement separately. What is talking about? I need to look at the okay. Let's see his solution. Okay. I got the idea. Uh, Intuition. Okay. Uh, maybe I'll try that. That thought part is little like confusing still. Um, I need to like think on that part. Okay. I'll be back in 10 minutes, and then we can continue. Okay. Yo, I'm back. Okay. No code. Yes, I solved this problem. Okay. Some things are derived while figuring out this problem. Most importantly, you must pay at least one worker his minimum requested wage. Okay, sorry. Which? What was the question? For each tree node, visit it with two states. A, its parent age is kept. B, its parent age is removed. Correct. This is where I reached. So each node is visited at most twice. Correct. The tricky part is how to pick the extra edges of each node to be deleted. Correct. This is the tricky part. This is where I got stuck. Like if I'm at a current node position, I have multiple nodes to it. I need to select, either I select or I remove. So which one to select and which one to remove was like the thing that I got stuck at. I am stuck at. So each node is visited at most twice. The tricky part is how to pick the extra edges of each node to be deleted. Okay, we can actually resolve it greedily. For node I, calculate all its child max sum with condition. A, its parent is kept. B, its parent edge is removed. Store A and B in an array. Say if we want to remove m edges, uh, okay, pick the top m def b minus a. Here comes the like actual tricky part. But at least I am like getting what he is saying. Calculate all its child max sum with condition. A, its child is kept, parent age is kept, and B, its parent age is removed. Okay, so this age is removed or this age is kept. Based on that, I will get the maximum sum for this back to its parent. And now store A and B in an array. Say if we want to remove m edges, we pick the top m diff b minus a. Parent should also be considered as a special child. A0, b parent age weight. Okay, with 0 I'm considering it as parent and its parent age weight. नहीं. This is something like what benefit I can have if we like do these subtractions. See, A is like parent is kept and B is parent is while parent is removed in an array. Say if we want to remove m edges, pick the top diff b minus a. Like this diff b minus a, what we are like making top diff b minus a. I need to like sort it. And why picking difference is giving me the more the difference value, the more. Why can't we directly pick so if we want to remove m edges, we want to remove those edges, we are not considering. Pick the top m diff b minus a. B minus a. Okay, parent child is, parent edge is removed and a parent edge is kept. Okay, let's have a chat GPT. I want to clarify this question. Like this is a good question, but I understood the concept. I can even try to code this part out. It will not be like that much difficult. I need to understand this half. Store A and B in an array. How this difference array helps us to prioritize the edge to remove by quantifying the gain or loss incurred by removing the edge based on the impact when included A or excluded B. Like prioritizing the edge to remove by quantifying the gain or loss incurred by removing the edge, each edge. Okay, These are the edges 5, 10, 3, 7, 6, 2. This is giving me like uh, if I'm saying A is like keeping the parent edge, B is like removing the parent edge. So if I remove, if I'm not including the parent edge, I'm getting a cost of 10, and if I'm keeping it, I'm getting a cost of 5, which is giving me like B minus A as 5, 4, minus 4, 7. After sorting the def, edges in order is like 4, 1, 2, 3, 4, 1, 2, 3. Correct. If you want to remove edge, if you want to remove two edges, m is equals to 2, select edge 4 and 1. Since they provide the maximum positive impact. So the more positive impact, because we are like doing B minus A minus B would have been I would have selected the negative one, but B minus A. Removing edges with the highest difference maximizes the overall benefit by either reducing the cost. If B is much smaller, or increasing the gain if B is much larger. By reducing the cost if B is much smaller, or increasing the gain if B is much larger. Okay, let me have this whole things. A tree structure, tree is connected a cyclic graph with every node. Two states of each node state, the edge connecting to the node to its parent is kept. The edge connecting node to its parent is removed. Goal: if we ask to remove m edges to minimize or maximize some value depending on the problem, we pick the edges greedily based on the difference area B minus A's. Tree where numbers represent edge weight. For each node I is the sum of values of its children if the parent edge is kept. Sum of maximum value of its children if the parent edge is removed. Difference calculation. The difference indicates the effect of removing the edge. Parent as special child. Treat the parent edge differently when calculating A and B. Parent edge kept. A of parent is equal to 0. No gain or cost from removing parent edge. Parent edge removed, B parent. Okay, parent edge kept. A parent of 0. No gain or cost of removing parent edge, because obviously I'm keeping the parent edge. Parent edge removed is like minus parent edge weight, removing cost weight. Okay. children node 3, node 3 we have here. Children 4 5, child 4. If parent edge 3 4 is kept, a4 is equals to 0, removed, a b4 is equals to like -1. Okay, let's see if code wise if there is something that I can understand more clearly. So this is my like dp vector. I call this dfs with 0 0 -1 will be like most probably its parent. We have four things over here: I, J, P and PW. J is W parent kept, J is equals to 1 erased. Okay, it's saying that if J is like 0, I'm keeping the parent, and if J is 1, I'm erasing the parent. No, so the code part that you you wrote is like horrible. Lots of if else. The code part is like far better of someone else. 3dp, let me see if this is a good. This is something that I need to like understand. I'm like creating the difference array, and then we are sorting the difference array. Right, and what I was doing here also just to remove just a second, let me see if I can go back a little more. Yes, so is parent age removed, or and parent, who is the parent, and this is the node. Now edges to remove, total number of edges in that array minus k minus is parent removed or not. We have a candidate list. Based on don't remove and remove, and don't remove and remove, on the basis of that we are sorting the array. If I'm not removing, like don't remove, solve is equals to any 0 node plus wait, remove solve is equals to any 1 node. Candidates dot add. So this is like the new node. If I'm not removing the edge. I am keeping the edge. Then I will add the weight. And then why are we like, is parentage removed? No, the parentage was not removed. That's why 0 and node. Is parentage removed? Yes, the parentage was removed. And if I'm removing the parentage, that means we are not adding any weight to this. Now, like, there are multiple choices that we have. I can select from one position, multiple choices. Now, which one to select based on difference array? There comes the difference array. So p1 of 0 minus p1 of 1, p2 of 0 minus okay, compare. So it's like based on b minus a, we are sorting the array. Candidate size and don't remove is like 0 and remove is 1. So edges to remove, I will directly add the answers for the edges to remove. Because that many edges we want to be removed. And don't remove and remove. Okay, yes, the difference array is if I'm keeping the parent edge and I'm removing the parent edge. Oh, with all libraries. Wow. Okay. Import error. They're all libraries and modules. No module named matplotlib. तुम्हारे पास matplotlib नहीं है. Why? It's the worst then. Okay, leave it. It's like the two array. Always I'm having two arrays. So current node, let me start from 0. um, is like current node removed or not, and the parent. Max sum tree. This is my current node. This is my parent node. Is parent removed? If there is no current node, then I'll return base case. I need to return this adjacency. Keep this adjacency list also. If current node is if adjacency list list, even I don't want this base case, because I am checking whether it is parent or not, and if it is not parent, I'll simply, so I'm not sure if I need this base case or not. Hopefully I think I will not need this base case. Correct. Okay, how many edges do I need to remove? Edges to remove will be something like maximum of 0 comma adjacency list of current node dot size will give me the size minus I need k. Okay, I need to pass k also. So subtract k and is parent. This will do what? This will tell me how many edges do I need to remove. Like 3 nodes to remove, and one if parent is already removed, then Now, okay, I'll have to have uh, vector int. This will keep like two values. This will be mostly two rows. First row will have if not, if parent not removed, and second will be if parent removed. Mm, cost uh, condition max cost. It will have two things. uh, Condition max cost of 0 is cost if the parent is not removed. Condition max cost is equals to cost if the parent is removed. Now I need to iterate over the adjacency list. Mm, child kind of adjacency list of now I need to check if current node is not equals to no, sorry, not current node. Child is not equals to parent. That means I need to, if the child is not equals to parent, what I need to do is then I can do the two calls. First, if we are considering not removal of this node, this edge, that means if we are not removing this edge, sorry, child dot second. If child node is not equals to parent node, we'll do what will, and we will have not removed will be max some tree. We'll go with child node. Parent node will be my current node is parent removed. I am not removing the parent. So I'll give send 0. Adjacency list will go as it is, k will go as it is, and wait. And if I am removing this edge, so child node will go as it is, parent will be like current node. I am removing adjacency list is this and k is this, right? Now after this I need to condition max cost dot push back. There will be like two things which will be pushed is not remove comma removed, not removed and removed. Now I need to sort this condition max cost, because this will be like for this specific node, right? So I need a comparator. Okay. Comparator. This will have like, this will give me two arrays, A and %B. Okay, and I need to like sort it based on the maximum value of a difference. So A of 0 minus B of 0 is like greater than A of 1 minus B of 1, right? Based on maximum difference array, right? Hopefully this will be the like comparison sort, which I'm guessing. Now now what I need to do, I sorted the array based on the difference array. I am saying that these edges I need to remove, or these edges are is what I need to take. So my answer for the current situation will be something. What? Mm, condition max. If I is lesser than edges to remove, I will. This is something that I need to understand. This is something that I need to understand. I'm still not very much clear about the part that we are doing here. Why we are taking only the removable part. Difference array. I'm sorting the difference array. I'm saying that for these I'm guessing I'm taking the cost when the parent edge is removed. And for these rest of them we are calculating maximum if we are removing it, if we are not removing it. um, I like, okay, edges to remove like these. uh, I can pick k edges, so I need to remove these many edges. So if I'm removing these many edges, removed, what cost did I get from them after removing those edges? What cost did I get? It's like if I am removing the current age, so I'm taking the second part as like removed. Okay, not removed is condition max cost of I of 0. Now if I is like lesser than, edges to remove, and like I, simple I is lesser than edges to remove, then like answer would be added with removed, else answer would be added with not removed, comma. And then we'll return the answer. Let's see, little skeptical about this. Uh, mm, why maximum I cannot call over here? Sorry. Where? 953. 80 and 200. Okay. Like parent node will always be this node. It's like a of 0 minus a of 1 only. What are we doing? Like the sort part is something not removed and removed. Their difference should be like maximum. So a of 0 minus like a of 1 should be like greater than b of 0 minus b of 1. That makes sense. Are we getting 80 as answer? Did I like wrote something wrong? I did create a edge list of 0, 1 and 1 and 0, right? Okay. Okay, now I need to add dp what all things I have, this and this. So 10 to the power 5 and 2 is what dp size would be. dp will be like edges dot size, edges dot size. Like these many edges are there, right? No, like those are not. It will be like adj list dot size. Maybe I'll add one more. Um, everything initialized with -1 and pass this dp. Now if dp of current node and is so I will be removing this. Sorry, I need to pass dp here, dp here. Let's try submit it and see. Oh shit. 701 out of 7014. What's wrong? Output is this, unexpected is this. If I use this test case, do I have any kind of like integer? DP is also long. Adjacency list can be of integer, it doesn't matter. The answer is like less and oh, that is correct. God. Okay, this was like a very much interesting question. On the basis of of removed drop, not removed in ascending order. Nice. This question is like insanely nice. Good. Okay, fine. I'll take a 10 minutes of break and then I'll come back and we'll continue again solving more hard level question. That'll give me more intuitions. I don't know. It irritates a lot, but yeah. If every penny is like worth it, then I'll do it. I'll try to do it. Okay, I'll be back in 5 minutes. Hello, I'm back. Let's get started. Okay. So, okay. This question was like literal, I would say, a confusing question, and this is the main crux of this question. Like this was not that difficult. This was like I pre-assumed that I reached to till this part. I knew how to solve till this, but picking up based on what condition and something like that was like mm. Now I got to know two things. Either I will pick and not pick. Based on that condition, I can directly return values, or pick or not pick, we can keep it somewhere and then we can return it. And like we do some manipulation and then we return it. Something like that. So minimum cost to hire. Let's look at some other question. Okay, I just wanted to see, is did he solve something like that? Quick select. Okay. There are n workers. You are given two integer arrays: quality, and wage. Where quality I is the quality of the ith worker and wage I is the minimum wage expected for the ith worker. We want to hire exactly k workers. Okay, I want to hire k two workers. To form a paid group, to hire a group of k workers, we must pay them according to the following rules. Every worker in the paid group must be paid at least their minimum wage expected. Okay. To form a paid group. Okay, we want to hire exactly k workers to form a paid group. To hire a group of k workers, we must pay them according to the following rules. Every workers in the paid group must be paid at least their minimum wage expectation. In the group, each worker's pay must be directly proportional to their quality. This means if a worker's quality is double that of the another workers in the group, then they must be paid twice as much as the other workers. Given the integer k, return the least amount of money needed to form a paid group satisfying the above condition. Answer within 10 to the power minus 5 of the actual answer will be accepted. Quality 10 25, wage 70 50 30, k is equals to 2. Okay, so quality is 10 20 and 5, wage is 70. There's something like paid group. We pay 70 to 0th worker and 35 to second worker and 35 to second worker. Each worker's pay must be directly proportional to their quality. This means if the worker's quality is double that of the another workers in the group, then they must be paid twice as much as the other workers. So it says that if we have this as 10 25 70 50 30, So if we have like this is the quality, and this is like, if I'm selecting this quality, kind of like I select 10. uh, Given the integer k, return the least amount of money needed to form a paid group satisfying above conditions. Answer within 10 to the power minus 5 of the actual answer will be accepted. Hmm. 3 1 10 10 1 4 8 2 2 7. So like 10 25 70 50 30. 3 1 10 10 1. Least amount of money. I didn't get the exact question. What is he's saying? We want to hire exactly k workers to form a paid group. Okay, we want to create a paid group. We want to have exactly k workers inside that paid group. Now, to hire a group of k workers, we must pay them according to the following rules. Every worker in the paid group must be paid at least their minimum wage expected. Okay. In the group, each worker's pay must be directly proportional to their quality. This means if a worker's quality is double that of another workers in the group, then they must be paid twice as much as the other workers. Okay. So like I created this I created this 2-member group, like 10 and 5. So 10 uh, has a minimum wage of 70. Now 5 has a minimum wage of 30. Right. So if I pick 5 in the each, if a worker's quality is double that of another workers in the group, if this worker's quality is double the another worker of the group, then they must be paid twice as much as other workers. But at least this, so say 70%, it should be like 100. Why it is 105? Like we need 3 workers, so we pay 4 to 0th. We pay 4 to the 0th worker. 13.333 to second and third workers are separately. Second and third workers is 13.33. How is like what's the intuition? What is the question exactly? We pay 4 to 0th worker. So 0th worker which has a quality of like 3, we pay him 4. What? Okay. Second and third workers separately. Second and third worker, like this has a quality of 3. A quality of 10 has a quality of 10. Now, how much times is greater than the other workers? It's something like that. So, like, what is the minimum? What is the current worker I'm picking up? So this is the smallest one. The next worker that I picked was 10. Uh, it's kind of a looking to me like a DP problem where I have those solutions. So 3 to 10. If I'm going from 3 to 10, how much jump? How many times jump that we have? Like, so 10 divided by 3, it's 3.33. So the values that we have is it was 4, right? So 4 into 3.33 something, or 3.34. Let's try 4 into 3.34. What's the answer? It's 13.3, or 4 into 3.33 is 13.32, or 4 into 3.33, 1, 2, 3, 4, 5. It's 13.333, 1, 2, 3, 4, 5. 1, 2, 3, 4. So like 1, 2, 3, 4, 5 till 10 to the power 5 1 is what I need to. So how many times is it double the minimum that we have till now? So I'll always try to pick the minimum and quality and price. Again, we have two arrays as quality and wage. uh, what if we have a difference array of this? Will that like make any sense? Which one to pick and which one to not pick? Like, pick and not pick, it's kind of a picking and not picking, but keeping in mind what is the minimum till now. Okay, I don't have any hint for this. This looks this Okay, one thing that I'm getting is whichever value is the minimum in the array, that value I'll pick. So I'll try to start with the minimum quality, uh, and then wage. Give me a minute, I'm getting a call. Just a minute. Okay, I'm back. So this looks to me like I need to. No, I may start with the minimum quality first, and then like pick and not pick kind of condition, and they're keeping track of the minimum quality one. So if the quality is increasing, I need to like at least pay him that much of wage from the from minimum. I'll like was the quality difference it is how much difference he is making that much amount and maximum. So so like it's maximum to minimize. It's kind of something like that. Mm. So it looks to me like a DP solution, but there might be a other way to approach it also. Kind of like a binary search. Is it possible? I need to select two students, two possible. So I need to like have the minimum possible answer. Pick and not pick. It looks very much similar to pick and not pick solution. Okay, let's try it. I need the answer to be in double. That's fine. Return minimum cost to hire workers. Okay, one thing that I need to make is combine this array. Qual quality wage coverage. They'll be of equal size, right? Quality of I of 0, wage of sorry, uh, quality of I, wage of I. I am adding 0 to it. Coverage. Okay, and then I need to sort this wage dot. It's like I'm selecting this. This will be my minimum. start with 0th index. I need k. I need the minimum mini to be -1 and Quavage, Quawh, Quavage. Okay, and let's see. So we have double. I'm creating a paid group. This paid group contains the current index, integer of k, integer as mini, and Quavage, quality wage. Now if IDX goes beyond, no sorry, not if current IDX is greater than or even equals to my Quavage dot size, that I'll return 0. Let's see. So initially if mini is equals to -1, that means this is the first time this method is being called. I would say my cost would start double, come on, double current cost will be 0.0. This is my, if mini is this, my current cost would be would be paid group current index +1. I'm going to the next index. I have my k, so k will like reduce k -1. Okay, I needed to select k went to 0, I'll return 0, and if IDX went more than Quavage, I would say, like, because I will be doing pick and not pick situation over here. I need to know if k is 0, then I will return 0 in that case. But if if current index goes beyond, I will look into it. Might be possible that I do not return 0 in that case. So paid group will be like, I'm going to select this one in this situation, or I will skip to the next. So this is my like selection or pick kind of condition. Current index, this mini would be my like, Quavage of current IDX of I was saying I'm talking about the quality, right? So it's 0. So this is my minimum quality that I am doing. If I'm not picking, so current cost will like not change. I need to minimize the current cost, right? So current cost, comma, paid group current index plus 1 key will go as it is. Coverage will go whatever we had in my mini part. Not pick. Here also we need to like minimize the current cost and the paid group. Okay, now if mini is not, then we need to do the bigger picture part. Then we are doing like and not pick situation but based on few conditions. Okay, so the first condition would be okay, I am picking right, so current wage will add. So core wage of current IDX will be added, and if I'm not picking, I will not add. Now there is something I need to do over here. Times with the mini will now be same. Mini will not change because I'm thinking of like the minimum one would be the actual one based on quality. So I have this mini quality. The next index that I picked will obviously have quality higher than mini. How much higher it is? Quality higher will be like mini. Quality wage of 0 will be like quality divided by mini, so multiplies with 1.0. This will tell me how many times higher it is. Now I need to select the maximum one. Double new cost will be like maximum of wage of current index 1 current index 1 comma quality higher okay, I would say I should not like for mini I should not pass the value. I should pass the index index, right? So current, like not current index, right? Current IDX. Quality edge. Okay, so this will be like wage of mini of 0 is like the quality, and quality higher of current idx of 0 minus divided by coverage of mini of 0. Now higher will be like multiplied with coverage of mini of 1. So whichever is like maximum, that many times the new cost will be, and current cost now will become as minimum of current cost comma. Now I'm picking this part, right? So this is my new cost plus pair group of current idx plus 1 k minus 1. Mini will go as it is, and coverage. If I'm not picking this index, right? Okay, so current cost is what I need to minimize, right? I'm minimizing, so I cannot take like 0. The integer, the answer can be, let's take integer max, and if it crosses I can take integer max over here. Okay, now it's time for not pick. When I'm not picking, my current cost would be minimum of current cost and direct pair group of current idx plus 1 k will remain as it is because we didn't change. Mini will go as it is, and coverage will also go as it is. And last will return the current cost. Is it pair group? Coverage, it's double, right? The answer is in double. I need to explicitly convert it. Ouch. 1530. But how? This will not change anything. What I know. What I did. Sorry. There's something. This will not change the answer. Current cost is equal to it will be same. Okay, can I see this? Core wage of IT of 0. Okay. Hey, hi, Cheese Fest. Hi, Rahul. Gampa. How are you? Okay, you are saying wouldn't selecting workers with quality 311 in example to give the minimum amount? 311 you are saying, picking these and this. Um, Possibly not, but let's see. Um, how you are saying is if we are picking like one, we have 7 for wage for one, and then picking one again that has a wage of 8, and 3. So 3 will be something. We have 1 and 3 times, so 3 divided by 1 will like give me 3, so 7 into 3 is 21. So for the third wage we will have to give him 21, which in turn this sum will be like greater than 30. So I think like we cannot pick this one. So based on this second condition, if you look at the second condition, this is like a little trick type of thing, but second point says means if a worker's quality is double than that of another workers in the group, then they must be paid twice as much as the other worker. So you can see if this is the worker, then this is the minimum waged worker. You need to learn multiplication again. Not an issue, bro. I think okay, this like gives me something like if I have same, then I need to like based on second I need to pick, right? Yeah. Okay, that will be like most probably handled with my sort part. I just needed to check like what wrong did I do. Are you getting any wrong intuition that I am going with on this question, Rahul? If you have some intuition or something that you think can be added in my solution, or you can like create your own solution, uh, it will be like really great for me to know it. So I'll be just okay. Let me know if you have something in your mind. I don't know what your approach is. Okay, kind of I'm using a knapsack problem, 01 knapsack, kind of picking and not picking. Um, I'm I'm picking one and then not picking. I'm trying all the possible mm combination of answer and then picking up the minimum one. That is what I'm currently thinking of. Maybe you can think of something else, or maybe you can add same. So we have 530, 1070, 2050. Right? Okay, we have this is like correctly sorted, and there's not an issue with the sorting part in here. Then there must be something wrong with uh, let's check what wrong I am doing. If you want to try this question, I'll just paste the link in the chat. Try this question. Let me know if you're coming up with some other approach, or even you can help me with the solution in this one. That would be really great. That will help you also to grow, something like that. So we have this current index starting from 0. I need k. For the first one, I picked as 530, right? Mini was like -1. I can pick, I cannot pick. Like both are the solution possible. So if I'm picking it, the uh, mm, mini would be like the current index. What I would say, like 0. So suppose I picked it. So what will happen? Like 30 will be added in my pick. So we have 30 over here, and then I again called with the next index, and the minimum is like 0th index. And this time mini is not -1, so I'll go in else part. Quality higher would be how much times it is. So quality wage of current index of 0, which is nothing but 10, divided by quality of mini of 0, which is nothing but 5, which will give me 2, right? So new cost would be, now there is something problem, like twice. Everyone should be okay. Okay, what if we do in the opposite way, like pick the largest one first and then do it? That'll also create a problem. Hmm, this is something. Hmm, like they're like both dependent on each other. One is dependent on the other, and the other is dependent on. So for example, if I have this as an example, if I have for 540 and 10 as 70, then in this case what will happen, they are twice the difference. So this cost will change to 80. So 40 plus 80, because he'll obviously going to take 80. So 40 plus 80, that is 120 in this case. And what if it is, this was 10 and 10 was like same as 70? What will happen is like 70 and divided by 2, like this will change to 35 then, and this will change to 70. So 70 plus 35, which will eventually give me 105. So in either of the direction, they are changing their values. It's not going in one direction. So maybe I can segregate two half separately. This half solving in a separate way, this half solving in a separate way. Like, is it possible to do that? Since the constraint is 10 to the power 4, we can initially try of n square solution, post sorting on quality, and then try to optimize over it. Yes. Okay. Let's think of the brute force approach then. Maybe that'll give us some intuition. So if I have like we can go for a n square solution for this. How? Uh, mm-hmm. Post sorting on quality. I sorted the quality. I can pick like one, and then based on that value, I'll try to pick the rest of the value. Is there something, some kind of priority queue involved here? Because one half, I am sure quality is sorted, but the wage is not sorted, right? So if quality is sorted, I do not have to look that much into the quality part, but I do have to watch the wage part. So what if we think in some kind of a priority queue way? Mm, we have a quality, we picked 10, 20 and 5, 5, 10, 20. We have 30, 70 and 50. I added 30 in my answer with 5 and 30. Now it's next values done. I know the quality is like greater. How much greater it is. So in that case, which one would be better? Okay, so I have like 5 comma 30 with me. Next the value that is coming is 1070. I know this 10 is like greater. uh, so obviously if I see in these two situation, like 10 is coming, it's 10 divided by 5 is like twice. So 30 would be multiplied by 2, which will give me you need to sort wage with respect to quality. Okay. um, you're saying I need to sort wage mm, with respect to quality. So you're saying like uh, I should be sorting quality, and but wherever it is coming equal, I need to sort on based on wage, or is it the opposite way? I need to sort the wage, and wherever the wages are same, based on that I need to sort the quality. So like any one of them should be like sorted, right? Why I'm currently thinking of sorting it based on quality first, because I know uh, whatever quality we have will be like smaller than the upcoming quality. So if it is smaller than the upcoming quality, I can say which what was the minimum quality that we had till now, and based on that I can like do the next part, like more dependencies on quality than the wage. That's why I'm thinking of the first way, right? Yeah, more dependency is on quality. That's why I'm thinking of sorting quality, and then uh, if quality multiple qualities are same, I need to sort based on wage. So in that case, do we require the larger wage to be at first, or the smaller wage to be at first? What should be the situation? I think going with the smaller wage first is fine. So normal sort would do the same thing. Then comes 10 and 70. Okay. I need to check. I have like the minimum value as 30, and this is twice. So twice of 30 is like only 60, and 70 is greater than. So what if we do the divide? This will increase, but this is not increasing. So I will increase this one to 35 and then 70, and then we have 20 with 50. So I know the minimum is like this one, and we only need to select two two values, right? So selecting two values, if a third value is coming, I need to remove some of the values. Till now my answer was 105. After 50 enters, uh, I can remove this 70, the topmost element, if the topmost element value is greater. I don't know, I'm just going random, man. This doesn't makes any actual sense. I'm just trying uh, to go through the situation. Mm, okay, there was something I I should, like, this is not the solution, but this says how we can try to approach it. Let's see. Most importantly, you must pay at least one worker his minimum requested wage exactly, otherwise you are wasting money. You need to make 20, that's 5 into 4. So 50 into 4 is 200. So 105 is minimum. Yeah, I agree to you, Rahul. That I need to make like 20, which will be like 5 into 4 times. So 105 is minimum, but is it like always going to give me the actual answer? Because I'm not getting the exact intuition that this approach will always going to work. That is something I'm thinking is somewhere I'm making mistake at. I'm not 100% sure that this will give me always the optimal answer. That's why I'm a little bit skeptical about it. Let's see what comes out. You must pay at least one worker his minimum requested wage exactly, otherwise you're wasting money. Who this worker is allow you to pretty easily assemble the rest of the team to minimize cost. You want to minimize the total experience in the group because the equation of total cost is given fixed worker with wage WF and the quality of QF, and total sum of quality in this group is QS. So cost is uh, weight. It'll work, I guess, and then we can check on BS to make it more optimal. Okay, let's have that solution in back of our mind, and let's see if that clashes with the way of with the approach that we thought with this solution or not. If it is like clashing, then we were like on the perfect track. Mm. What I am guessing is a little like not unsure about the solution uh, of that. Uh, like every time we can pick one wage, and based on that we can we can select the rest of the mm, uh, people. So okay, if we are going for a n square solution, if we select this 5 and 30, we can go we'll try to look it's double. Okay, 60, no, 70 will take it. This is half divided by the no, okay. Okay, who this worker is allows you to pretty easily assemble the rest of the team. To minimize cost, you want to minimize the total experience in the group, because the equation for total cost is given fixed worker with wage wf and quality qf. Total sum of quality in the group qs will be is like cost wf into qs divided by qf. Thus given a fixed worker that is paid their wage, you can minimize the cost by minimizing q's, the total sum of quality in the group. Thus a given fixed worker that is paid their wage, you can minimize the cost by minimizing q qualities, the total sum of quality in the group. However, you who you pick as the worker with the fixed wage determines who you can add to the group. This is because the r because the ratio of quality to minimum cost will mean you would pay some workers you added to the group less than the minimum wage given the wf uh, given fixed worker with wage wf and quality. Right, this is totally correct. This is what we are doing, calculating the new cost with. As you read this, why don't you take an example and run these steps over that example? Yes, yes, why not? I'm just I was going through. Okay, let's try it. Let's try it. Not an issue. 3, 1, 10, 10, and 1. Wage. So this is my quality. This is my wage, and this is my k. I need 3 workers. Let's see. So this cost is saying me something. I'm like, he's saying select a fixed worker, and based on that the group's value will differ, right? So how to select the that fixed worker? Like I need to create a member of 3 over here, so I need to select a, a member based on that rest of the values of the group also will change. So that is a fixed, and wage fix, quality fix, and rest of the groups QS will change based on that. But yeah, but there can be like 2 separate ways, right? Mm. Okay, let's see. There are not lots of practical over here. Who you pick as the worker with the fixed wage determines who you can add to the group. So this fixed, based on this fixed selection, how whom I can add is more important. This is because the ratio of quality to minimum cost will mean you would pay some workers you added in the group less than their minimum wage. Given the wage fixed, Q fixed above, it can be derived that you will pay any worker with the quality Q added to the group wage fixed QS divided by QF into Q divided by QS, which simplifies to like fixed divided by quality of that with quality of fixed, right? So quality of fixed should be like always like smaller if I want to like increase the wage. With the above equation on hand and your knowledge that you pay on any worker in the group their minimum wage W, we can derive a more useful equation. W is equals to fix into Q divided by QF. We simplify. Okay. This means that the ratio of WF divided by QF must be the highest in the group you assemble. From here, solving the problem involves a few steps. Yeah, I didn't get this part. What did he said? Okay, this till here it's fine. With the above equation on hand and knowledge that you must pay any worker in the group their minimum wage W, you can derive a more useful equation. It's fixed wage of fixed into Q divided by Q fix, which simplifies to, oh okay, he did what, wage should be like lesser than equals to wage of fixed into Q divided by QF. Are you a student prepping for interviews? probably um, not a student, but yeah, I graduated last year, so I have like 1 year of experience. What about you, Rahul? I think I have less brain. I'm not able to understand this. Probably I think you are probably like more into it. Yes, currently I am working. Oh, great! You got a 4 year of experience. For me, it's like I just started, so 1 year of experience. I have. Solving this problem involves a few steps. Sort the input array by WF by QF. Weight of fixed by quality of fixed. So dividing these to assemble a list of k workers with the lowest WF and QF ratios. This is the group with the smallest possible WF to QF ratios, dominated by a fixed worker verb at the last index. You should be able to like compute the cost of the group of this group of workers using the first equation derived above. Work along the rest of the sorted WFQF workers. For each additional workers, remove the worker with the highest quality from the list from 2, and then add in your new next highest. Now he's confusing me a lot. So based on the ratio we are like defining, like how did we came to this, and why I was not able to like think in this way also. Something he used is priority queue, but a little more different way. You had this thing in your mind, Rahul, like, like you like, can you explain if you have anything in your mind based on these mm, points 1 and 2, 2 and 3. Nope. It's like he's coming to a solution based on the ratio of both of them. Because why we came to the ratio part, because both were like very much dependent with each other. So I like, one way I was thinking, like I always encountered few questions where there were like two things to handle. So keep one thing fixed, and based on that try to solve the second one. I was thinking in that way, to keep one thing fixed, so the quality to be like in sorted order, and for the rest of the part, for wage I was thinking of doing something, but he did what he took the ratio, and based on that ratio is doing like he added a third filter to it, and based on third condition he is like handling these values based on the ratio. Interesting. It's kind of interesting. Okay, let's see. Let's try one example, and see what happens. Based on work and quality, he is like defining the ratio. So four, so 3 divided by 4 will be somewhat 1.33. 1 divided by 8, 8 divided by 1, 4 divided by 3, no, 8 divided by 1 will be 8. 2 divided by 10 will be 0.2. 2 divided by 0.2 again. 7 divided by 1 is 7 again. Now based on this, let's sort this. What will happen? 0.2, 0.2, 1.33, 7 and 8. So actually 0.2 was what? Let me write that those values also. Was 10, 10, 1.3 was let me write in a better way. This is like 3 by 4. No, sorry. First one is quality, right? 10 by 2, 10 by 2 again. It's 3 by 4, and 1 2 3 4, 1 2 3 4 5. Which one I missed? Okay, for 7 it is 1 by 7. For 8 it is 1 by 8. Even though this is the opposite, I should have written in opposite way, but fine. Okay, so this was like quality over weight, quality weight, quality weight. Now assemble the list of k workers with the lowest these ratios. K workers with the lowest. This is the group with the smallest possible of WF QF ratio dominated by a fixed worker. And the last one, you should be able to compute the cost of this group of the workers using the first equation derived above. This. Work along the rest of the sorted WF by QF workers. For each additional workers, remove the worker with the highest quality from the list from 2 and add in your new highest WFQF worker. Okay, this will allow you to keep track of your WFQF. Okay, this is saying like kind of I'm going with a sliding window approach, like remove one, add add one, and like, based on some condition or computation I need to remove one and add one. Okay, so we have these three window because k was 3, so I have this 3 window. For these 3 window, what cost would be incurred? So we have like weight as 2 and 2. So 2 plus 2, because their qualities are same, and now this quality is so he's saying no, it's not a sliding window. I still need to have a priority queue for this, because he's keeping the highest quality. He will be remove the worker with the highest quality from the list from 2 and add it in a new highest. Oh yeah, okay. I should like no. Based on quality, we are working max queue add co-worker, current worker. Sorry. So we have workers. Where is workers? We have this as worker. What I'm doing is worker dot add I. Okay, based on that, I am like sorting the index. So this index is sorted. Oh my god. Okay, 0 1 2 3 4. 2 3 0 4 and 1. So this is my collection dot sort. Workers will have like this order 2 3 0 4 1. Now I am this is like index, right? Quality dot length, right? Yeah. Okay, max value quality sum I added in my max queue current worker. Current worker is nothing but 2. So added in my priority queue as 2. Quality sum will be quality sum will be like quality of co-worker. Current quality of co-worker is 10, so quality sum will be updated with 10. If max queue size is greater than this, no. If it is equals to, then also no. I will like simply insert plus 10 in my quality sum and index 3 in my max queue. It's still not equals to 3. I'll add one more 0 to it, and the quality sum is 3. Now if it is equals to max queue dot size is equals to k. Now I need to do something. Result is equals to result into quality sum quality sum is nothing but 23 into wage of current worker divided by quality of current worker. Oh my god. Okay, why he did that? Why we are not doing like every time? This is what I was doing also. Like this second part was wage, so wage. Sorry, not here. Mm, here. Meaning of zero. That should be multiplied. So wage of current worker divided by quality of current worker into quality sum. What is this? We did the quality sum as 23. Quality sum into wage of current worker. Current worker is 0. 0. Zero's wage is 4. So we have like 4 divided by quality of current worker is 3. 4 divided by 3 is like 1.33. And quality sum is 23. So 23 into like 1.33. And I need to like minimize this. And if size is greater than k, what I'm doing is I'm subtracting quality max q dot remove. Okay. Even this current worker. Okay, I am going with workers index. I'm a little bit confused about this solution. I don't know. I need some other explanation. Every worker in the paid group should be paid in the ratio of their quality compared to other workers in the paid group. So for any two workers in the paid group, we have wage of I is wage of j is equals to quality of I ratio quality of j. So we have wage of I quality of I is equals to wage of j quality of j. We pay wage to every worker in the group with the same ratio compared to his own quality. Every worker in the paid group must be paid at least their minimum wage expectation. Correct. For every worker, he has an expected ratio of wage compared to his quality. So to minimize the total wage, we want a small ratio. So we sort all workers with their expected ratio. To minimize the wage, we want a small ratio. Correct. So so we sort all the worker with their expected ratio and pick up the k first workers. Now we have minimum possible ratio of k workers with and we their total quality. and be their total quality. We have the minimum possible ratio of k worker and with their total quality. As we pick up the next worker with bigger ratio, we increase the ratio for whole group. Correct. Meanwhile, we remove a worker with the highest uh, quality so that we keep k workers in the group. Meanwhile, we remove a worker with the highest quality so that we keep k workers in the group. We calculate the current ratio into total quality is equal to total wage of this group. We redo the process and we can find the minimum total wage because workers are sorted by ratio of wage by quality. For every ratio, we find the minimum possible total quality of k workers. Why we are working on the so we have worker dot pushback ratio based on its thank you, Shivam bhai. Workers dot pushback weight wi divided by qi quality. Find and then quality. Sort. I sorted it based on the least ratio, obviously, and then we created a priority queue. Priority queue will keep the maximum at the top, highest at the top. Now quality sum is worker of 1, so I'm adding the quality and I'm pushing the quality inside my priority queue. If it is greater queue dot sum, I'm removing the top and also I'm removing that from the priority queue. If it is equals, then this is something only I need to understand. I have quality sum, all the qualities till now, into a worker of 0. Workers of 0 is what? A ratio of weight by quality. Like, this is the only part that I'm confused with. We are like handling many things here, but you have any idea how we are like handling this part? Equals to k. Like total quality sum till now. Into worker of 0. Worker of 0 is nothing but a ratio. So quality sum till now into No, I'm not paying concentration, working on my solution. Oh, okay. Not an issue. Try it by your own. That's great. Hmm. Pick up key first workers. Now we have a minimum possible ratio for key workers and we their total quality. As we pick up next worker with bigger ratio, we increase the ratio for the whole group. Meanwhile, we remove a worker with the highest quality so that we keep key workers in the group. We calculate the current ratio into total quality is equals to total wage of this for this group. This is what he is calculating. Current ratio into total quality is the total wage of this group. Is what he is saying. Okay, how is it total wage of this group? Three is the total quality. We have the wage. Current ratio as 4/3. How this is like the total wage for this group? Which of I is equals to ratio into where ratio is a constant value chosen that satisfies the minimum wage requirement for total quality represents the sum of all the workers' qualities in the group, thus multiplying by the smallest possible ratio uh, that satisfies all workers with the total quality, you get the minimum possible total wage. Worker 3 to 1. Pick two worker K is equal with the smallest ratio, worker 3 and 2. Okay. Total quality 30 plus 20 is equal to 50. Ratio okay Rahul, it's really great that you were here with me solving the question. It really motivated me a lot, so thank you very much. Hopefully we'll meet again. Thanks a lot. 30 plus 20 is 50. I'll try to solve this question. I'll try to understand it as best as I can, so that if we meet again I'll be able to explain you in a better way. Total quality is like 50 ratios from worker 2 as it is the highest ratio that it satisfies all chosen workers. Subbing you. See you later. All the best on the problem. Bye. Thank you very much, Rahul. See you later, bro. Bye. We need to pay each worker wage proportional to the quality while ensuring the wage meets or exceeds the minimum wage requirement. The ratio wage by quality must be same for all workers in the group, and it should be at least as large as individual workers. While the highest ratio for a group K of K workers, to ensure every worker is paid at least their minimum wage. The wage to quality ratio we choose must satisfy most demanding worker. The one with the highest minimum ratio. Imagine you're hiring okay, let's see this. Good. You're hiring a team of workers and each worker has a different minimum hourly wage requirement. Mm, okay, imagine you're hiring a team of workers, and each worker has a different minimum hourly wage requirement which depends on their skill level or role. To keep things fair, you decide to pay everyone the same hourly wage, but it has to be high enough to meet the highest minimum requirement among them. If one worker demands $15 per hour and another worker demands $20, you can't pay everyone $15 per hour because the second worker won't accept it. Instead, you have to pay at least $20 to satisfy everyone. You multiply by the highest ratio because fairness. Every worker gets a wage proportional to their quality, but it must satisfy the most demanding worker. The highest ratio ensures that no worker is unpaid based on their minimum expectation. Bigger ratio, we increase the ratio for the whole group. Meanwhile, we remove a worker with the highest quality so that fifteen into 70 divided by 10. Current ratio is like wage divided by meanwhile we remove a worker with the highest quality so that because workers are sorted by ratio of their wage by quality. For every ratio we find the minimum possible total quality of k workers. So the lesser the quality, the greater the value will be. The lesser, so the more the quality. So like we have 50. So we have 50 divided by 20, which will like give you 2.5. 70 divided by 10 will give you 7, and 30 divided by 5 will give you 6. 2.5, 6 and 7. Add the quality of this is like 20 plus 10, that is 30. And the ratio is 6. Now remove 20, left with 10, add 5, that is 15, and then there is sorry, this is quality 20, and then plus I added 5, that is 25 into 6. This will give me something, and then I removed this, and then I added 10. So 10 I added, which will give me, like, eventually it will be 15, and plus the ratio, that is 7. Into this is like just I don't need this wage dot. Workers dot push back. I only did it with wage by quality. Why can't we do it by quality by wage? Total quality plus is equals to if PQ dot size is greater than K, Total quality minus. He always does it with the comma separated. Result is equals to minimum of result or multiplied. Okay. Kilo price. Okay, quality is baskets, wage is price. 10 kg of apple has a 70 price, 20 kg 50, 5 kg 30. That is 7 rupees per kg, 2.5 rupees per kg, 6 rupees per kg. We have 3 baskets of apple, 10 kg, 20 kg, 5. Each basket costs this. Unit price of apple in each basket is this. The rule is when you buy multiple basket, you have to pay the highest unit price for all apples. Example, if you buy 20 kg of 2.5 per kg, 10 kg of 7 rupees dollar per kg, together you have to pay the highest 7 for them. So 20 kg plus 10 kg multiplied by 7 kg. Okay, that's confusing, but okay, fine. Okay, I think I'll take a break for now. Uh, I need to order some food and then I need to eat. I'll take a break of probably 50 minutes because I don't have anything to eat and I'm feeling hungry. And then we can start again. Okay, I'll see you later after a short break. Hello, I'm back. I'm a little late. I was still figuring out what to eat, what to not. Okay, so let's try some other question. Maybe find critical and pseudo critical edges in minimum spanning tree. So I already know like what is minimum spanning tree. Maybe I'll try this one. Given a weighted and directed connected graph with n vertices numbered from 0 to n minus 1, and an array edges where edges of I is equals to ai bi wi represents a bidirectional and weighted edge between ai and vi. Yeah, maybe I'll try one medium level question just for some kind of motivation. Whose hard level questions are, I don't know. Okay, let's go. A minimum spanning tree is a subset of graph that edges that contains all the vertices without cycle with the minimum possible total edge weight. Is this something articulation point or something like that? Find all the critical and pseudo-critical edges in the given graph. Graph's minimum spanning tree. MST edge whose an MST edge whose deletion from the graph would cause the minimum spanning tree weight to increase is called critical edge. On the other hand, pseudo-critical edge is the is that which can appear in some MST but not all. Note that you can return the indices of the edges in any order. Find all the critical and pseudo critical edges in the given graph's minimum spanning tree. An MST edge whose deletion from the graph would cause the MST weight to increase is called the critical edge. The figure above describes the graph from the shows all the possible MSTs. Notice that the two edges 0 and 1 appears in all MST. Therefore, they are critical edges. So we return them in the first line of the output. Edges 2, 3, 4 and 5 are only part of some MST. Therefore, they are considered pseudo-critical edges. We add them to the second list of output. Okay, I need to find like all critical edge. I need to find a critical edge which appears in all possible minimum spanning tree. That edge, like I can if there is like two edge, I don't know if there is possible or not if two edges, but if there is two edges I can return any of them. Return the indices of the edges in any order. See, finding all possible MSTs and then checking edge by edge is not a solution for this. What I I can understand from this is like, do you have any idea on what could be? What is this? 11220132664353. a bidirectional and weighted edge. What is this? In some MST, but not all. See, this is articulation point or something. Crisco solution. Tarjan. MST with Kruskal algorithm. Union and find with Kruskal. Enumerating edges with explanation. As a baseline and denote the MST as a weight graph origin MST to generate critical and critical each edge. If deleting the edge and recalculating the MST again makes MST total weight increase or can't form MST, then the edges goes into critical list. हाँ सही बात है. First we'll do what? We'll find the MST. After finding the MST, we'll note the weight, the minimum weight, minimum spanning tree, right? So now we already calculated. Now for every edge, we will check if deleting the edge and recalculating the MST again makes the total weight increase or can't form MST, then the edges goes into critical list. If you right. So we have this edges list. We sorted edges. Just 1 second. I don't know why. Do we need this sort? Okay. Original MST, get MST. Now critical and non-critical edges. If original MST is like lesser than get MST, then I'll push it into the critical edge. If original MST is equals to get MST, like after deleting this edge, non-critical edge. So I do not have to go to a specific edge. I have to block an edge. Okay, he used union and find algorithm. Correct. This Kruskal algorithm or Prim's algorithm can also be solved. Like MSTs can also be solved using union and find solution. Don't you think so? I have this edge. I iterated over the rest of the edge and try to figure out. Just a second. Okay, so let's write the union and find based on rank. So we have a class. Let me create a union and find class. Union find. Okay. I don't need privates. I need public. Okay, he declared it. Wow, man, he declared private below public. Great. That's why I was searching for where is the parent and rank. So I have this union and find constructor which will give me size, and I'll resize union and find with n, or maybe let's have a rank dot push back one. Everyone will have its own rank, right? So this will create the union and find. Now I need to have find will return a value. Sorry, little cough, I don't know. Okay, now if parent of x is equals to x, parent of x is equals to find parent of x. So this is find. This will return nothing, or maybe true or false. Bool. Unite. I need x like a and b. Int x is equals to find a int x, y is equals to find b. Now if rank of x is greater than rank of y, then parent of y is equals to x, and rank of x plus is equals to rank of y. Else parent of x is equals to parent of y, rank of y plus is equals to rank of x. Let's simply return true from here. Now only one condition that I want: if x is equals to false, I'll return false. Okay. I need to have MST, minimum spanning tree. I have these edges. I just need to unite them. If deleting the edge and recalculating the MST makes the MST total weight increase or can't form MST, then the edge goes into critical list. If we force adding the edge to the MST by first adding the edge to the MST edge set and run the standard MST algorithm for the rest of the edges and find that the MST doesn't change, then the edge goes into pseudo critical list. This is because if an edge can be in any MST, we can always add it to the edge set first without changing the final MST total weight. So I have this union and find UF as passed and weight is 0 if pre-edge is not equals to -1. And so initially it is -1. Suppose it is -1. Original MST pre-edge is -1. Blockage okay, -1 is like blockage, pre-edge is nothing. So original MST it is not equal to -1, it is -1. So I'll do what if I is equals to edges dot size block, that edge needs to be blocked. So if that is the blockage, I'll continue. If that is not the blockage, because initially the blockage will be like -1, right? I'll just find the edges of I in edge union and find edge of 0 is equals to if both has the same parent, I'll simply continue, else I'll unite them and weight of that will be like added. If they are already united, it will return false, as it will return true, right? Because he sorted it based on the cost, minimum cost, that's why he is not doing anything. So he sorted it based on the cost. That is the reason everything is happening. Now okay, critical and non-critical. What I'm saying is get MST by blocking this edge. Get MST. What is this pre-edge? If we force adding the edge to the MST by first adding the edge to the MST edge and set this and run the stand for the rest of the edges. because if an edge can be named, we can always add it to the edge set first without so this is pre-edge. If it is pre-edge, I'm adding that weight, and I'm also uniting that pre-edge. Okay, okay. Okay, let me write mst. It'll return me value. Is it integer only? Okay, so it integer mst minimum spanning tree. For this minimum spanning tree, we needed few things. It's like get mst. So we will be having edge list, right? So we will get this vector int ampersand ed edges list, and minimum spanning tree would do all the hard part. So it'll create a minimum. First it'll create a union find object with size n, and there are like n edges, so I need to pass n also over here. That uf is initialized. If okay, uf if union find dot underscore union, like to do it as a dge edge of 0 comma edge edge of 1. If union and find is equals to like true, if union gives me true, that means it was united. So wait, I need to have wait dot wait plus is equals to dg edge of 2. I'll simply return. And I need a blocked edge also, right? Blocked edge int pre edge is equals to -1. Now if okay, now I need a loop. if I is equals to block date, I don't have to do anything. If not, then I'll do vector int. And at last I need to check like every node is, hey, I can do something like that. Int components and components is equals to this. Every time is complete, if components is equals to 1 return true, else return false. So now uf dot if uf dot is complete, is true, then return wait as return -1, or maybe integer max value. Okay, now I need to handle the pre-age part. If pre-age is not equals to -1, pre-age if pre-age is not equals to -1, I need to unite this and add the weight in my weight. So weight plus is equals to edges of pre-edge of 2 and uf dot union right. Next, okay, we have this we will do what, we'll sort edges dot begin comma edges dot end. I can add comparator directly, right? This is how to add a comparator directly. Hey, you remember this. Don't forget this. Constant, we will take exactly as it is, as a vector and ampersand b, and inside only will do return a of to based on the price. We will be sorting it. Why we did this? We have the original MST. Null MST cost is like get MST. Get MST will have n will get this edges blocked edge as -1, and it's fine. This is my original MST. Hey, do we needed to return the indices? It's the graph. Okay, that's why he pushed one more thing, like 0 1 is the edge, and 0 and 1 1 2. So like these two edges are always there. Two edges 0 and 1 appear in all. Two edges 0 and 1 appear. Oh, that's why I got it. I needed to push indices for int I. Because we are sorting it, the indices will be here and there. So edges dot push back edges of I dot push back I. Now I will do what edges dot size plus I. I need the critical and pseudo critical edges. So for that, critical pseudo this is like a blockage that I am blocking this edge, and I'm saying find the MST. So if get MST is greater than original MST cost, then CRTI critical dot push back EDGS edges of I of 3, else if get MST is equals to original MST PSEUDO pseudo critical dot push back edges of so get MST will send n will send edges block edge as I and pre-edge. I'm fixing this edge. I'm saying don't include this edge and then find the answer. And in second I'm saying try this as a pre-edge. Edges this will be -1 and this will be like I right for the second one. And we can directly critical PSEUDO pseudo. क्या बात है भाई for the first time is complaint. Nice. Oh, got accepted in the first time, so I know how the solution is working. So this was like union and find solution, prims and Kruskal. I know one more way to find the MST. So I might add this to my GitHub repo. Where is did I keep? Where did I keep? Where did I keep? Just a minute. Let me check. That must be somewhere here. Yes. Yep. Graph. Minimum spanning tree. Frames. Union and find for MST. Okay, and then let me push it to my GitHub. Okay, pen in terminal. I'm not sure. MST using union and find. Git push. Done. Okay, you can also check. I have added it in my GitHub repository. It's in my description box. You can check my GitHub repository. You'll get there. I may just show you once. MST using union and find. So you have a minimum spanning tree, union and find solution. Okay, great. So it was great learning today. I think I'll stop by now. I need to go outside for some work to do. So that's it for today. Hope you enjoyed the stream, and hopefully I'll see you next week, possibly with another live stream. I'll be back again. Why my hairs are going like this? So much stuff. Okay. See you tomorrow. No, not tomorrow. Probably next week. Bye bye.